Hey everyone, in this video we'll be getting hands-on pretty directly. You can think of this as a continuation for the pre-trained scikit-learn model deployment video we had. It should be above in the playlist and also link it in the description just so that you can access it. But the reason I wanted to get hands-on with this and have this as kind of the follow-up for what we're going to be working with next is a common question I get, and something that I honestly struggled with when I was first new to SageMaker, was that I didn't know what the best way to debug SageMaker endpoints was. It sounds pretty stupid now and it was a little naive on my end back then, but I'd wait for the endpoint to create almost every time, and then I'd check the CloudWatch logs, and we'll kind of uncover those logs and metrics a little more in depth as we move on in this series too, and I'll follow up with that. But I'd basically wait. If you remember, that endpoint took a few minutes to create, and a problem for me was if my script or any of the inference logic I had was not accurate, I didn't know until I invoked that endpoint itself. And that cost me a lot of time because this can take a few minutes, right? And that's kind of a bit of a nightmare to debug with if you have to wait for that endpoint to create every time. And what I'm going to show you is the simpler and kind of proper way of debugging your containers and your endpoints that you're working with for SageMaker. And we're going to do that via Docker. So it is a prerequisite, I'd say, for this video to have some Docker experience. I'll link the containers kind of guide I had as well, just so you can follow along, but I'd recommend having a bit of an understanding. But we'll walk through the general commands, and I have some Docker commands here that I'll attach and link to the Git repo for this entire series that you can follow along with. But what we'll do quickly is we'll hop into our notebook environment, and right now I'm working in SageMaker notebook instances. Right here. You could also optionally use Studio as we have been, but you have to install Docker there, and full honesty, I was just feeling a little lazy to do that. But you could go that route and install the Docker kind of setup there as well with the script. But here we'll just use a notebook environment because that comes with Docker pre-installed essentially. If I go in here, you'll notice that you can recognize many of these artifacts from our previous example itself. So I guess the other prerequisite here is just maybe watch that video to understand the exact use case we were working with, if you'd like to understand the exact kind of model artifacts and data we have here. But this will apply for any SageMaker resources or models that you might be working with. If you notice here, though, I have my artifacts. I have my model data, this joblib file, which was the serialized scikit-learn model file. I have my model.py, which is my inference script, my requirements text, and serving.properties. And like I said, most oftentimes there is an error when you're trying to debug, especially as you're adjusting to a new model server, and maybe there's some new protocol for that server that you're still getting familiar with in terms of how you structure these artifacts. We want to capture these errors early. I don't want to have to adjust a line in the script every time. I don't want to have to adjust, I know this is a little basic here, but the serving.properties in a format that server expects every single time, because it's going to take a few minutes for each iteration if I have to wait to create the endpoint every time. So what we can do is, and I'm going to link this documentation here that I'll go over, what we can do is we can leverage Docker, because at the end of the day, like we said, SageMaker, there's a container which is fronting that web/model server, and that's providing the runtime environment for you. And then there's the associated hardware, right? So we can leverage Docker, right, to start this container ahead of time. Whether you're bringing your own container, which we'll discuss in another video, or if you're using one of the managed images that SageMaker provides, all you need is for your container to have a server listening on port 8080. So this is the port essentially for inference that we're exposing. And that container needs to be enabled, and this happens by default, right, for the managed images, to accept post requests on the dash invocations path, which is where your inference logic goes, and dash ping, which is essentially a health check, right? And if you were ever to build your own container, we'll go through a sample for this too later in the series, you need to comply with these two contracts here. By default, all those pre-built Docker images that we were talking about, whether it's DGL serving, Trident, TorchServe, they all have this already implemented within their contracts itself. So that simplifies our life a little here. And what we're going to do is, like I said, we have Docker installed. You can verify that by just typing the Docker command there. And I've run some of these commands ahead of time, but Docker images, we'll run this again later in a second. I'll explain what that means. But right here, if we go here to the commands that I have associated, we first authenticate Docker with ECR. And the reason for this is ECR is storing all these pre-built images, and even if you build your own image and push your own image, you're going to push it to ECR. So we need to make sure that we can talk with ECR to be able to pull this image, and this command will enable that. This should take a few seconds if you're running it for the first time, but it'll basically authenticate you there. What we then do here, and I want to just kind of quickly break this down, is we're going to start the container so that we can actually invoke our model. And if we see here, you might have to change this right here for this portion. But here, I've essentially put the path right here for my model artifacts. So this is the local path that's pointing towards my inference script, and my model artifacts, once again, structured in the way that my specific container or model server is expecting. And in this case, that's DGL serving, as we talked about. Here, if you notice, this is another specific nuance that you'll notice within SageMaker. There's certain directories where the model artifacts are loaded, essentially. So when we post them into S3, our Docker container, this is the path, essentially, where those model artifacts get captured. So we specify that because this is, once again, a SageMaker-specific construct right there. And if you notice, we expose port 8080 here, and most importantly, we specify the image that we're working with. So I've already ran this once, so you won't see this happen here. But when you first run this, this Docker image is going to get pulled down from ECR. And then this port is what we're going to expose, essentially, for inference right here. So if I take this Docker command, I'm going to run this here. And like I said, since I've already ran this and pulled this image down, you're not going to see it, but it might add a few seconds where it pulls this image essentially down from ECR. And what we're going to see here is our model server getting kicked off. Traditionally, in a SageMaker endpoint, you can see all this same kind of logs in the CloudWatch logs for when the endpoint is first getting started. And you'll notice right here, port 8080, any kind of serving.properties files we've enabled. This is DGL specific. So these are all default values, but in this serving.properties, I can basically tune these and adjust them as needed. And if we see here, we now can invoke our model because we have this exposed right here. And what I'll do right now is I'll pull up another terminal. Let's just split screen this right here. And what I've done here is I have a sample curl request. And this is once again mimicking that invoke endpoint call. So if I go to the get series right here for all the samples we're working with, and I'll link this once again in the description for reference, we'll see right here that our invoke endpoint call is what we're trying to simulate, essentially, right? So we want to simulate this without having to create the endpoint. So I'm going to take the same request body and the same content type and just present it in that curl request, right? So I'm going to take this, I'm going to say this is the post request that I'm going to be sending in. And I specify once again right here, if you notice, port 8080 and dash indications is that path for inference that we're working with. And we're able to see sample inference. Now this is a very dummy, simple use case, right? So if you have any custom logging, any kind of things that you want to try, you can now simply just shut down this container, which will take a second, adjust your kind of model artifacts or scripts or anything that you're working with or playing with, and then kick up this container again and run that sample inference essentially. So now this saves us so much time, right? Because we don't have to go through the whole process of that endpoint resource allocation, endpoint creation, and any debugging we can see quicker here and adjust our model artifacts. So this is the key, right? Whether you use one of the managed images or your own, you want to go this route because it will save you a lot of time. And I learned this painful way in terms of just debugging, adjusting your model artifacts, and especially, right, I can't emphasize this enough, when you're new to a model server. So these model artifacts are structured in a way DGL serving expects. And I'm very familiar with DGL, so I understand how these artifacts need to be. Let's say there's something like try an inference server or torch serve where you don't have the most experience with it, and you don't know what kind of structure your artifact's meant to be in for that model server. Rather than going through that whole kind of tarball creation process, endpoint creation, we can nip those errors early. So if we don't structure in a way that try an inference server, for example, doesn't like, we can then quickly analyze this and see from the server itself via Docker, right? Okay, this is not being picked up here, this config file. This config file should actually be located in this directory or that directory. So there's different nuances, especially as it comes to learning different model servers, and you might become more familiar with them over time, but as you're learning new ones, and I still am to this day, right? It's important to kind of use this process here to really simplify this debugging kind of setup so you don't waste too much time on that, and you can quickly just get to serving your model itself. And the last thing I wanted to call out, right, is I ran this notebook instance, right, on a C5 2X large. So that's where this notebook and this environment is technically running on. if you ever want to run load tests, for example, without creating a SageMaker endpoint, what you can do, right, often is go to EC2, wherever there's AMI with Docker installed, basically, and what are dependencies that you need. And you can basically say, here are my artifacts, here's the image that I'm going to be using, but you also want to select compute that will mimic what's realistically going to be behind your endpoint. And this becomes especially crucial when you're maybe load testing or performance testing your models, right? Because you want hardware that's going to mimic what's behind your endpoint. So that's also another common use case I see, at least personally, where if you want to simulate this without the SageMaker endpoint, you need the hardware to kind of mimic it and to simulate or replicate the environment as closely as possible. And just to kind of end this video, make sure to kill this container. I think that terminal's bugging out, but we can run this command right here to see what's still running. What I'm going to do is I'm going to do a docker stop, grab that container ID right there. And if that doesn't stop, let's just maybe run it one more time. Apologies for the confusion there. Let's see what's happening. Cool. And then you can see that there's no more containers listed. And lastly, you can also validate whatever images you've pulled down, right? So if I do a Docker images right there, you'll see that DGL image has been pulled down from ECR. And this once again applies even if you're building your own container, which we'll cover in later videos. But yeah, I think that's it for today. It was a shorter video, and it was mainly with the idea of simplifying this real-time inference process for you and debugging these kind of model servers, containers, or any scripts you might have in a simpler format. If you found it helpful, it would mean a lot if you could like and subscribe. And thank you as always for watching. Feel free to leave any feedback or any questions in the comments or reach out to me directly. And we'll be back soon, and we'll cover more advanced topics such as auto-scaling, container performance, load testing, a lot of things that I've alluded to. I promise it's actually coming. So stay tuned, and thank you as always. Appreciate it.